Hi, this is Mr. Gillum, and today we're going to take a look at an example out of your Practice and Problem Solving book about equivalent ratios. And we're going to talk about Alina. Alina uses 12 red beads to make 4 bracelets. How many red beads will Alina need to make 12 bracelets? How many red beads will Alina need to make 20 bracelets? So what you can do is you can make a table showing the number of bracelets that can be made with different numbers of red beads. The pairs of numbers in each column show the ratio of red beads to bracelets. Notice the ratios are all equivalent. The table shows that Alina will need 36 red beads to make 12 bracelets. Alina will need 60 red beads to make 20 bracelets. That was a lot of reading, so you may want me to rewind and listen to that again if I read it a little too fast. But what I see basically is this. We need 12 beads to make 4 bracelets, and I see that value right there, 12 to 4. Now this table is a little different than tables we've made in the past. In the past we might say beads and bracelets and make a table, and we would start maybe with 12 beads to 4 bracelets. So 1, 2, 3, 4 bracelets and 12 beads go together. And so we formerly, like last lesson 2, we would probably talk about a unit rate and try to figure that out. So if we were talking about 12 to 4, we could divide both the 12 and the 4 by 4 to see how many per 1 that it would be. We would see that it is 3 to 1. And so I would know, okay, well, 3 beads for every 1 bracelet. That would mean 6 for 2, and 9 for 3, 12 for 4, and I could figure out what 5 is by following 2 different patterns. I could say, okay, for the beads, we're adding 3, and for the bracelets, we're adding 1. The relationship between the corresponding values, meaning above and below, would be multiplying by 3. 2 times 3 would be 6, 3 times 3 would be 9, 4 times 3 would be 12, 5 times 3 would be 15, and so on. And so if it says how many beads will Alina need to make 12 bracelets, we could say, okay, well, she wants 12 bracelets, and this relationship says if I multiply that by 3, we'll have proportional, I shouldn't say proportional, we haven't talked about that yet, but we have an equivalent ratio to all these other ratios in the table, and 12 times 3 would be 36. And they talk about you would need 36 to make 12 bracelets, and that's true. Also, we could do the same thing with when it asks how many will she need to make 20 bracelets, well, we could say, okay, well, if there's 20 bracelets, then I multiply that by 3, we would need 60 beads. And so that's one of the ways that we've solved it using unit rates. We talked about 3 beads for 1, so we could use that pattern between the corresponding values to figure out 60 for 20 bracelets and 36 for 12. This table is just a little different though. Instead, they followed a different pattern. The pattern that they followed in this case, and neither way is right or wrong, or more right or wrong than the other, I should say. It looks like that they didn't follow a specific pattern all the way through, but they made sure that their ratios were proportional. So we can see 3 to 1, 6 to 2, 12 to 4, 24 to 8. Yeah, that still follows the proportional relationship that we have down here, multiplying by 3. 12 times 3 is still 36. 16 times 3 is 48. 20 times 3 is still 60. So they did a little bit differently than maybe what we've done in the past. They kind of skipped some numbers in between. They start by adding 1, but then they add 2, then 4, and so it looks like a pattern, but then they continue to add 4. And that's fine. They were just trying to abbreviate their pattern so they didn't have a huge long table all the way down to figure out what it would take for 20 or for later on, 12, and then later on 20. So just because there's not a pattern from left to right doesn't mean that this is an incorrect table. So at the top, initially I thought, oh, well, they're just doubling it each time. 3 doubled is 6, 6 doubled is 12, 12 doubled is 24, and then I thought, uh-oh, 24 doubled is not 36, but are these relationships still the same? Are they equivalent? ratios, 3 to 1, or 24 and 8, and 36 and 12, and I realized that they are, and they just continued that pattern so that they could hit multiples of 20 and 12. So they skipped a few numbers, but each of the numbers in this table are still equivalent ratios. So that's okay. So it's very similar to what we've been doing. I hope this helps a little bit when you're doing your practice and problem solving.